Okay, so here we go. So looking at question number 2 now. Pi over 2. That's a different system. We were just talking about the degree system. The degree system was made up so that... I got to plug in my thing here. Let me wait. All right, so let's take a look. So again, if you have a unit circle, all the way around is 360 degrees or 2 pi radians. So what they're going to have us do now is convert between the two systems. Oh, that's not true. Yeah, well, yeah, let's do that. Let's convert. Where I'm going to take that pi over 2, which is radians. It's in the radians, it's like Celsius or something, and I want to convert it back to Fahrenheit. I want to convert between the two systems. So what could I do? Well, remember what that pi is? Here, if halfway around is 180, in degrees anyway, and all the way around is 2 pi radians, what's halfway around in radians? Pi. So pi radians must equal 180 degrees, huh? You tracking with me on that? Again, halfway around a circle is 180 degrees because 360 is all the way. And halfway around a circle is also pi in the radian system because all the way around is 2 pi in the radian system. So halfway around is pi, radians, 180 degrees. Therefore, pi and 180 must be the same thing in the two different systems. Pi radians is 180 degrees, isn't it? So what that means is that's a real convenient bridge between the two worlds. If you want to go between radians and degrees or vice versa, there's the bridge you walk on. Pi radians is 180 degrees. So that means I'll take this pi right here and I'll put 180 in its place. Because pi is 180 degrees. 180 degrees is pi. See how the pi has been replaced with 180 degrees? And 180 divided by 2? 90 degrees, which you probably already knew. Pi over 2 is up here. It's 90 degrees, huh? So it's a right angle, and we're done with the question. So right angle. Now, you might have been able to do that without converting. If you just like, no, hey, I know pi over 2 is straight up, it's a right angle. Great. You don't need to do this. In a minute, we'll have to convert anyway. So I just wanted to start showing you that. Does that make sense how I converted? Anytime you see a pi, just pop a 180 in there. Because pi radians is halfway around the circle, is 180 degrees. That'll be our bridge. Okay, so there's a word, our first little word problem. Find the radian measure of the central angle of a circle of radius 4 yards that intercepts an arc of length 10 yards. This sounds kind of weird. What's it talking about? It's saying that you have like a little angle. There's an angle. It's made of angle at random. And there's an arc. Like that, you know, a little piece of arc. A length there. The radius is 4, which that means from the middle to, that's 4, that one's 4, either one, both of them, whatever. From the middle, you know, like we're imagining there's a whole circle here, you know. And we're just looking at one part of it. The radius is from the middle to the edge. The radius is 4. And the arc length is 10 yards. This, you know, along here is 10 yards. It doesn't look like it on my picture. My 10 looks smaller than my 4. But, well, good enough. So far, so good. You understand what they're saying? They're saying the arc length is 10. The 4 is the radius. So what? They want me to find the central angle. Well, there's a formula I need to give you. Arc length, S. I do not know why they use S for arc length. They should use A, I would think. But they use S. I have no idea why. S, but they always do it. It stands for arc length. This right here, this arc length, is R times theta. So that's an important formula. I will allow you to use, on every exam, a 3x5 card. Because I don't think memorizing math is super important, but just knowing how to do it. So S equals R theta. I write that right on my 3x5 card for Monday's test. S equals R theta. That's an arc length formula right there. So anytime they talk about arc lengths, anytime you see the words arc of length, you'll think S equals R theta. Going to use S equals R theta every time. So here we go. S equals R theta. Going to use that. What's the R? Radius 4. What's the S? What's the arc length? That's the 10. Length of arc, 10. You can see my writing there. Arc of length 10. The theta, I don't know. That's what I'm trying to find. That's like the x. That theta, that's just a Greek letter. It's like an x. Just a letter. Just a circle with a slash through it. It's called theta. It's a Greek letter. Anyway, just pretend it's an x, whatever, same thing. But they always use theta for angles. I don't know why, but they do. They always use that. It's a Greek letter. All right, so how do we solve for that theta? Theta's over here saying, I want to be alone.
Divide both sides by 4.
Yeah, how do you know you divide by 4 instead of subtracting 4? That's
Because
correct.
it's right next to the... So
Yeah.
multiplication problem.
They're right next to each other, no symbol in the middle, which means times, huh?
Yeah.
And the way you get rid of times, the opposite of times is divide, huh? You good with that? Yeah, so you divide. Whereas if that was 4 plus theta, I would subtract the 4, wouldn't I? But it's times, so the opposite of times is divide, yeah. Whenever you divide one side, you divide the other. 10 divided by 4, calculator, you can use calculator. 2.5, that's all right, that's the answer right there. That's the angle. Now, when I say 2.5, that doesn't really look like an angle, does it? You may look at that and go, what is that? That's an amount of opening. That's an amount of opening between two straight lines. That's an angle. 2.5, what is that? Is that 2.5 degrees or radians?
Radians.
It's radians. How do you know it's radians?
Because that's what it's asking us for.
Because that
Find
was
the
the
radian.
unit on the radius.
That was the unit. And there's no degree symbol. That'll be the easiest way to tell. If there's that little circle, then it's degrees. If there's not, it's radians. Period. A lot of people think it has to have the pi to be radians, but that's not right. That's not true. It doesn't have to have the pi. You tracking with me? Let me say that again really clearly. If it had a degree symbol, it would be degrees. If it doesn't have that symbol, whether it has a pi or not, if it doesn't have the degree symbol, it is radians by default, because you're one or the other. So it's radians, and we're done. And that's an amount of opening.
And again, how would you tell, like, let's say you give us that amount the amount of radians right there, how would you tell, like, convert that in degrees and know?
Yeah, good question. In just a minute, we'll convert radians to degrees. Basically, you'd need to do what we saw in that animation, where you multiply by pi over 180. Yeah, we'll do that. Converting units. I learned in chemistry, actually, not in any math class. Chemistry about converting units. Basically, so we want to take 70 degrees, and we want to end up going to radians. That's our desire. That's what they're telling me to do. Convert from degrees to radians. So how do we do it? What I learned in chemistry is make everything look like a fraction. So put that over 1, any whole numbers over 1, right? Make it look like a fraction is helpful. And then multiply by another fraction that'll do what you want it to do. Now, what do I want it to do? Well, I want to go from degrees to radians. That's what the whole question's about. They gave me degrees. They want me to go to radians. Okay, what I learned in chemistry is that units cross-cancel just like numbers do. That's what I hadn't realized before. That you can cancel units just like you do. I knew numbers cross-canceled, but I didn't know you could do that with units when I took chemistry in junior college. Chemistry 3A. I don't know if you're taking that. Anyway, so degrees can cross-cancel. So now, what's the bridge again? What's the bridge between the two worlds of radians and degrees?
180.
Yeah, pi radians is 180 degrees. That's the bridge we're always going to use to connect the two worlds, right? Because those are both half a circle, aren't they? Because 2 pi was all the way around, so pi is half a circle, and 360 is all the way around in degrees, so 180 is half a circle. Those are both half a circle. So that's the bridge. That's the easy bridge. So what am I going to do then? One of these is going to go on the top of the fraction, and one of these is going to go on the bottom of the fraction. How do you know which you can put the 180 on the top and the pi on the bottom, or the pi on the top and the 180? How do you know which way? Sometimes it's one way, sometimes it's the other. Depends on the problem. Do you know how you know?
Because the degree goes on the opposite.
Yeah, because you want the degrees to cross-cancel. Exactly. If degrees are up here and I want them to cancel, I got to put them down there and then they'll cross-cancel. Always be thinking what you want to get rid of. That's what I learned in that Chem 3A class. Oh, you put the units you want to get rid of down below, then I'm gone from degrees, I'm out of degrees, and so pi goes on the top. Do you realize this is just a big fancy 1? It doesn't look like a 1, but it is a 1. Why? Because it's the same thing over itself. Remember, these are the same in the two different worlds, aren't they? They're the same. Half a circle, half a circle. They're both a straight line opening, aren't they? They're both half a circle. So even though they look very different, they are the same. Pi equals 180. Pi radians. So I'm multiplying by 1. So if you multiply by 1, you're not changing the value. You're just changing the look, aren't you? That's why this works on that. Yeah?
Question, why didn't you use that bridge? Pi equals 180. Why not 2 pi equals 360?
Great question. That would work totally fine too. I'm just doing this because it's easy. Because it's a nice clean pi. Really good question.
Simplified.
Yeah, it just seems a little easier, but you're totally right. You could use the 2 pi is 360 or many other things too. Yeah. All right, so anyway, so there we go. So what do we have then? You just multiply straight and straight. 70 times pi, 70 pi. 1 times 180, 180. We're out of degrees now. I'm not going to write a degree symbol, notice. Why not? Well, because degrees canceled. See them going away there? Bye-bye degrees. We're out of degrees. We're in radians now. That's our answer, except they want it simple. You know, all fractions must be simplified. If you can reduce that fraction, top and bottom. How can we reduce that fraction? Yeah, cancel the zeros or divide by 10. That's what really cancels the zeros. You're totally right. Just cancels those zeros out, huh? 10 goes into 70. 10 goes into 180. So reduce fractions whenever you can. Divide top and bottom by 10. So that's 7 pi over 18. That's our answer. We just converted from degrees. 70 degrees is the same as 7 pi over 18 radians. It's the same opening between two lines. Questions on that? So I use that pi over 180 as the easiest bridge. And I figure out which way to put it by what I'm trying to get rid of. Trying to get rid of degrees. Question?
So like, would you be able to like cross multiply 70 times 180 and then the other one?
Good question. Cross multiply instead of cross cancel is when you have an equals in the middle. Really good question.
Okay.
Yeah, cross multiply is like if you have x over 2 is 7 over 3. You go times. See how there's equals in the middle?
Yeah.
Yeah, cross multiply is real similar kind of thing in math, huh? That's when you have equals in the middle. When you have times in the middle, you cross cancel
Okay.
on that. Yeah. Yeah, try that one. So see if you can convert 195. Give you a second. Convert 195 degrees to radians. Number 5. So your homework will be the same, just be different numbers. Oh, and I don't think I've said so. If you want to bring your laptops, phones, get half your homework done in here, I am great with that. Feel free. Usually about half the students will have their phones out, their laptops, bring them to class. They'll be kind of watching me do something, and then they'll do something, and they'll get half their homework done. That's great. Use your time as efficiently as you possibly can. So that's fine with me to bring your stuff and get online and get some of your homework done. So 195 degrees. So I want to convert, right? So where do degrees go?
Oh, wait.
Degrees go away. They do go away. So they go on the bottom to go away, right? So 180 degrees, bye-bye degrees. And pi on the top. Is that good? That's our bridge. It's the easiest bridge. So there it is. Now, the 195 is over 1, really. So I'm going to go 195 pi over 180. Sorry, I'm getting a little scribbly there. Yeah. Start it over there. 195. Yeah, then we got to reduce that, huh?
Is
that what it is? So yeah, just use your calculator. So I don't know everything about those numbers right away, but I just noticed 5 goes in. That's all I can tell. 195, 180. I know 5 goes into both of them. So just use your calculator. Divide top and bottom by 5. Some of you guys have nice calculators. Do it all at once.
That'd be 33.
What is it? Is it 33? Thank you. 33 pi over 36. And then I notice what goes into 33 and 36. 3, huh? You do another step. Divide by 3. Top and bottom, that'd be 11 pi over 12, and that's the final answer. So you do have to reduce the fractions as far as they will go. Yeah, sorry, that's goofy math. No, I should notice too. Yeah, 39 divided by 3, 13 pi over 12. Better?
Yeah.
Sorry. Yeah, just let me know when I do that stuff. Good, I'm glad you're a group that will speak up. Sometimes people just let me do crazy things and go on to the next problem.
Yeah.
I'm glad you don't. Good, I will do that again. Okay, pi over 3. So now we're going the other way. We're going from radian world back to degrees. See how we're starting radians and now we want to go back to degrees? So, starting with pi over 3 radians. What again is the bridge between the two worlds?
180.
Yeah, pi is 180. Let me write that above. Right? 180 degrees is pi radians, isn't it? So you know what that means? You know what the easiest way to do this would be?
180 divided by 3.
You could do that, but I'm just going to say, look, if pi equals 180 degrees, if it's the same as, right, equals means same as, then why don't I just substitute? You know what I mean? Just take this 180, put it right in the place of pi, because pi is 180. I could pop 180 right in for pi. They're the same thing. That's what it says. That's the bridge. They're the same thing in two different worlds, two different, ways of saying an opening, like degrees in Fahrenheit. Two different systems. They're the same temperature, really. They're the same angle opening. They're both half a circle. 180 degrees, pi radians. So therefore, that's the thing I do, is if there's actually a pi already there. I know this might, you might think, why didn't we do that before then? Well, if you look back, see, there wasn't a pi already there. So I couldn't do that. I had to bring in my own stuff.
We had to create it.
We had to create it. See the difference? There wasn't a pi. Last couple of problems, there was not a pi already there. So I had to bring it in. But if there is a pi already just sitting there, just pop it in there. Just pop in 180 in the place of that pi and then just clean it up. What's 180 divided by 3? How many times does 3 go into 18?
6.
6, so that'd be 60 degrees and we're done.
That's easier.
So if there's a pi already there, just pop a 180 right in there. Good? I'm going to keep on moving. And all right, 4 pi over 3. So now they want us to figure out the look. Remember, I don't know if you noticed on the practice exam, we saw one like that. So here we are. Like I said, homework just becomes test question, same thing. So how do we do this kind of thing? How do we take 4 pi over 3 and figure out which one it looks like? You might be able to just kind of know the radian system directly. That's great if you can. I'm going to go ahead and just convert to degrees. I just think better in degrees myself. So I'm just going to convert like that. So I'm going to take 4 pi over 3. And how do I, what's a 3 in the bottom there? How do I convert that to degrees?
Like the 180.
Yeah, right? Because we've already got a pi, huh? If you've already got a pi on the scene, just pop in the 180. Because pi is 180, both half a circle, huh? So that's, pi times 180 degrees over 3. You can use your calculator. You get 240. I'm doing it because I'm just dividing. 3 into 18, 6 times 4, 24. You don't have to do it by hand, though. If you want to just do it by calculator, just multiply 4 times 180 divided by 3. You'll get 240 degrees. How I did it by hand again is I went 3 into 18. When I'm working by hand, I always do the divide first because that makes numbers smaller. That's easier. So 3 goes into 18 6 times, and then 4 times 6, 24. Throw the 0 on the back, 240. Okay, so what? Well, I know what 240 looks like. Are you comfortable with 240? Remember, 0 starts here. That was by common agreement. They could have made 0 straight up like a clock, but they just said 0 is going to be straight to the right. That's where we're going to start all the angles. And then we're going to open them up. They open upward. Down would be negative, huh? If you go down, it's negative. Up, it's positive. So up, next problem will be negative. So go upward, how far? 240. So if I go straight up, that's 90, remember? If I go here, that's 180. Down here's 270.
So it's got to be in between them.
So it's down here. Yeah, do you know the quadrant numbers? This is quadrant number 1, number 2, number 3, and number 4. 4 quadrants. Like that. So there we go. 1, 2, 3, and 4. So yeah, so 240 is over here somewhere in the third quadrant. So which one of those pictures looks right? A, B, C, or D?
C.
Yeah, it's that one, huh? Be able to do that on the exam next Monday? You saw that one? There was one just like that in a practice exam? Yeah.
You know how 2 is supposed to be less than 180? So what is 240 supposed to be? Is that supposed to be like something else?
Say that first line again. 2?
Obtuse is supposed to be less than 180.
Oh, no. Obtuse is... Oh, yeah, you're right. You're right. More than 90. I was thinking 90. Yeah, you're totally right. More than 90, less than 180. So say your question then one more time.
What is a 260 supposed to be? What kind of angle is that?
Yeah. It's a big one. I mean, honestly, there's not a special word. Yeah, good question. Yeah. So it's not obtuse, huh? It's even bigger than obtuse. Yeah, we don't have any special names. Well, maybe there is. I don't know.
Look at the inside angle, it would be obtuse.
Yeah, usually they'll look at the smaller, but yeah. Yeah. Then maybe there's a name. I don't know about it, if there is. Yeah. Negative means down, right?
Yeah.
Okay, so let's just convert that to degrees so it's easier for us to deal with. So negative 5 pi over 3 equals negative 5
It would be negative 300.
times 180 over 3. Just pop in a 180 there
So
in the
we
place of pi.
see again.
It's all we see. That's the rule. 3 goes into 18 6 times. You can just do the calculator. Minus 3. 5 times 6 is 30. So minus 300. See how I did that? Okay.
And
So now now careful. This is a negative angle.
it's B.
So negative goes down. Anybody for D? We got A, B, and C.
I can't see.
All right, so negative goes down. Let's start right here. This is 0 by common agreement in the math science world. That's 0. And then we're going to go down. Now, if I go down, this would be negative 90, because that's right angle. This would be negative 180. So I'm going down and around. This would be negative 270. Keep going. It's even past that. It's negative 300. So it's somewhere right around there, isn't it? It's not all the way to it's not all the way around. It's not negative 360. It's not all the way. So it's right around there. Negative 300.
And I'll still be in quadrant 2, even though it's negative.
That's quadrant 1 actually. This is quadrant 1, 2, 3, and 4. Yeah, 1 starts right here where everything begins. That's where the angles, positive angles anyway, first begin. So that's 1, and then just as you open up, it goes counterclockwise, 2, 3, 4. So that's, quadrant 1 there. So it's C again, isn't it?
How would that look in radian?
So the look would be the same. The look is actually the same in radians. Oh, I see. But you mean like what would the radian angles be? Yeah, this is minus pi over 2. Because remember, 180 is pi, so 180 over 2, that's minus 90. Yeah, so in radians, every 90 degrees is half a pi. So this is minus a full pi. Remember, 180 is pi. This is minus 1.5 pi, or 3/2 pi. And so this is minus 5/3 of a pi. In other words, that's 1 2/3 pi, which is more than 1.5. Negative. Yeah, that's why it is. So there's negative 1.5 straight out, and that's more than negative 1.5. It's negative 1 2/3. Good. But yeah, you can just change to degrees and do it in degrees on that. All right, better keep moving. Let's try this one. 11 pi over 3. That's going to be more than a whole time around. So let's take the 11 pi over 3. Let's convert it again to degrees. You don't have to if you're real comfortable with it. You can just leave it as it is, but I'm going to convert it. 11 pi over 3. So 11, the pi again is the 180 over 3. Reduce it. 3 goes into 18 6 times. 6 times 11. 660 degrees. So that's 660. Now that's more than a 360. That's more than all the way around, isn't it? Right? So like if you're starting here at 0, draw the unit circle here. Starting here at 0, and you go all the way around, that's 360, and this thing keeps on going. How much after 360? Well,
300.
yeah, subtract 360 from it, and you'll get 300 extra after the original 360. Am I going too fast? Does that make sense what I'm doing?
Yeah.
So I'm saying you go all the way around 360, and then you keep on going. Beyond that, 300 more degrees, which is how much is 300? Well, this is 90. This is 180, 270, and a little further, right about here. 300 more after a full circle 360. Does everybody see what 660 is? It's a full 360 with 300 left. So I did a full 360 and then 300 more than 270. So it's up down there. Yeah, it looks like A, doesn't it? See how A went all the way, kept on going to the fourth quadrant?
So when you graph it, you gotta put the little
Oh, no, it's multiple choice.
Oh, okay.
Yeah, you would just select A. Yeah, so back on the, okay, so they're saying, find a positive angle less than 360 that is coterminal. That's a fancy word. What does coterminal mean? Bless you. Coterminal means, means with, whenever co's on a word, co's with, like a co-pilot's with him. And terminal means ending, right? To terminate is to end, right? The terminator, ending people, right? So coterminal means ending in the same place, ending with. So that means find another angle that ends in the same spot. That's what they're saying. You got negative 980. Who knows what that is? Zip, 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 around a bunch. They're saying, what's a positive angle that's going to end in the same place as that? That's what they're saying. Well, how do you do that? Just add a bunch of 360s. Because anytime you add 360, you're in the same place. Do you realize that? Like, what if I say, hey, I'm pointing at that corner, all right? And now I'm going to add 360, okay? I'm still pointing at the corner. Or, oh, no, now subtract 360, okay? I'm pointing there. If you add 360, you're still pointing at the same place, huh? You haven't really gone anywhere if you add a full 360 or subtract a full 360. You'll end up in the same spot you were before. So if I take minus 980 and I add 360, whatever I get is going to be the same place. It's going to be coterminal, ending in the same place, isn't it? I haven't changed the ending place.
Right.
So what is that? Minus 6, just use calculator. And then you've got to keep going until it gets positive.
Right.
Because they want it positive. So just add another 360. Is that one minus 260? No. Is that right?
260, yeah.
260, am I right? Okay, 5, yeah, 6. Okay, so I'm at minus, I'm still negative. So one more. Add another. So I just keep adding 360s. Again, when you add 360, you haven't changed your ending place. Positive 100, right? There it is. That positive 100 ends in the same place as negative 980. They're all the same. Does that make sense? So anytime you add 360s or subtract 360s, you're in the same place, really. Co-terminal, same ending place. They're giving us a gigantic angle, 29 pi over 4. And they want us to find coterminal, right? You know, ending in the same place, but no, it's the same angle, same spot. That's a positive angle less than 2 pi. See, this is huge. 29 pi over 4, that's way more than 2 pi. How do you know? Well, 4 goes into 29 a lot more than 2 times, doesn't it? Right? So that's a lot more than 2 pi. And remember, 2 pi is all the way around in radians. Remember, 2 pi is all the way around in radians. Pi is halfway around. So they're giving me an angle way more than all the way. That's all the way around quite a few times. And they want me to boil it down to be less than 2 pi. In other words, less than, they don't want these extra spinnings around. They want it to be less than all the way around. Less than 2 pi. So anyway, long story short, what do you always do on any problem that says coterminal? You add or subtract 360. Like I was saying, pointing at the corner, if I subtract 360, I'm still pointing at the corner, huh? So if you add or subtract 360s, you're still coterminal.
So
you're still ending in the same spot.
Are you going to subtract 2 pi?
Yeah, but here I'm in radians, so instead of adding and subtracting a full circle by 360, if I was in degrees, I'm in radians, so how do you add a full circle in radians?
2 pi.
2 pi, because that's a full circle in radians. I am going to subtract, because I'm too big, so I've got to subtract 2 pi. And I'm just going to keep subtracting 2 pi until I bring it down under 2 pi, within one circle. So now how do you subtract 2 pi?
You need to find a common denominator.
Common denominator. The two, remember, whenever a whole number is interacting with a fraction, put it over 1. But you got to make the, right, because same thing. You got to make the denominator 4.
So 8 pi.
So
Or
multiply
8
top and bottom by 4.
8 pi over 4.
Yeah, and it'll become 29 pi over 4 minus 8 pi over 4. That's 21 pi over 4. Good so far? We're not done yet.
Keep going.
Got to do it again. Well, how do you know? Well, because this is still bigger than 2 pi. How do you know? 4 goes into 21 more than 2 times. Goes like 5 times with a little change, huh? So I got to do it again. See what I'm doing? Am I losing you? I'm just subtracting 2 pi's. Why? Because that's all the way around. If you spin all the way around, you're still facing the same direction when you're done. Huh? So I can add or subtract 360s add or subtract 2 pi's all day long. And I'm still ending in the same place. So I'm going to do it again. Bring it up here. Take 21 pi over 4. And this time I'm going to subtract again 8 pi over 4. Whoops, not 8 pi over 2. 8 pi over 4, because that's a fancy 2 pi. Isn't this a fancy 2 pi? 4 goes into 8 2 times? That's a 2 pi. But common denominator. So what do we get? 21 minus 8? 13? 13 pi over 4? Am I done?
No.
How do you know I'm not? Remember, I'm supposed to get under 2 pi. Am I under 2 pi now? No, 4 goes into 13 more than 3 times. 3 times 4 is 12. Goes in there more. I'm still over 3 pi, aren't I? I'm not yet under 2 pi. Like they told me. Less than 2 pi. So one more time should do it. One last time, subtract 8 pi over 4. A fancy 2 pi. That leaves 5 pi over 4. Done. That's less than 2 pi, isn't it? 4 only goes into 5 one time. There's my answer. That's the same spot as the original 29 pi over 4. Same ending place. Because I just took out a bunch of full circles. A bunch of 2 pi's.
When did we say, couldn't you like convert it back into 2 pi, like just for visual something, like,
Change it back into degrees, you mean?
no, not changing it back into degrees, but like, you know how you said keep it less than 2 pi? Like, you know how you multiply by 4? Wouldn't you, is there any way to turn that back into like 2 pi just so it can like...
Turn which part? The original or the final one?
The
Final answer?
Yeah.
Yes, you could add 2 pi's back to it.
Yeah.
So, that'd be 8 pi over 4 for common number. You could add 8 pi over 4, add 8 pi over 4, add 8 pi over 4, and it would eventually go back to 29 pi over 4. You're just adding a full circle every time. You're adding 2 pi, which is 8 pi over 4. Does that make sense? 8 pi over 4, 8 pi over 4, that is 2 pi. So everybody see that? That the 8 pi over 4 is 2 pi. So anytime you add or subtract 8 pi over 4, you're adding and subtracting a full circle. So you're coterminal, same ending place. Question?
Yeah, what is ending? Is it the arc?
Well, yeah, the angle opening. Good question. Yes. So what we're saying is, you start out here, and the angle. It turns out it's 5 pi over 4. What is that? I don't know. What is 5 pi over 4? It's about right here. Anyway, this angle ends at 5 pi over 4. There we start right here to the right. That's 0. And this is how big the opening is. That's the angle is more than a straight angle, actually. That's a little bit more than 180 is what that is. That's where it is. That's the same thing as if you went zip, 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 and ended at 29 pi over 4. It's the same place. That's what that's saying on that. Yeah.
Can we just convert the 29 pi
To degrees? You could do degrees if that's easier for you, if you want to mess with these fractions. Yeah. Fair enough. It's a little bit of work that way, though, because you're going to have to convert it back at the end. So I want the answer back in radians. Yeah.
My question is more about the program itself. It says that you need to type in your answer in terms of pi. Does that mean that like when you click that little text box?
That'll be up. Okay, so what would we do with this one? Same kind of thing. Coterminal, that always means, add or subtract 2 pi's, or 360. So we're in the pi world. We're in the radian world. So what are we going to do? They want us to make it positive. See what they're saying? Find a positive. That's negative right now. They want to make it positive.
Then it would have to be.
So am I going to add or subtract 2 pi's? I'm going to add. It's negative. I got to make it positive. I got to add a bunch, don't I? So start adding 2 pi, 2 pi, 2 pi, 2 pi, until that thing becomes positive. Now, how do I add 2 pi? 2 pi over 1, but you got to get a common denominator.
12 pi over 6.
Yeah, 12 pi over 6 is what it should be. Multiply top and bottom by 6, that's right, 12 pi over 6. So just keep adding 12 pi over 6 until, probably need to do it about, I don't know what, 4, 5 times. It's going to take 5 times. The answer is pi over 6, is that what you said? Is it 11? I don't know. I thought it was positive 1 pi over 6. What I'm thinking. Maybe I'm messing up though. Trying to do it in my head. I think it's positive 1 pi over 6. What you got? Oh, is that what you got? Okay, good. Yeah, positive 1 pi over 6 is what you should get. Just keep adding 12 pi over 6. Add 12 pi over 6. Add 12 pi over 6.
That also should be positive.
Until it's positive. They say find a positive.
Oh.
Yeah, right up here. They want it positive. So yeah, so I just say, okay, add 12 pi over. How did I get that? I took 2 pi over 1, which is a full circle, 360, and I multiplied top and bottom by 6 to get 12 pi over 6. That's a fancy 2 pi, isn't it? So that's a full circle. So I just keep adding. Now, how many times? Well, the first time you do it, you get negative 47 pi over 6. Then you do it again. You add 12 pi over 6, and you get negative 35 pi over 6. And then you add 12 pi over 6 again. You get negative 23 pi over 6. Bring it down here. Negative 23 pi over 6. Add 12 pi over 6 again. You get minus 21 pi over 6. Oh, yeah. 11. Thank you. And then one more time. Add 12. We can't stop there. We got to get it to positive, right? They said positive. So one more time. 1. Positive 1. It's positive now.
So
Pi over 6. Pi over 6, in other words. Yeah, you don't even need the 1, huh? The 1's invisibly understood. It's pi over 6. And there we go. We got the answer. Is that good on that? Questions? Is it all good? All right. Let's keep going. Okay, so the formula we use, so it's probably still on the board, maybe not. I never put it on the board. All right, S equals, what's fun? R theta. Yeah, so that's what we use for arc length. S equals R theta. So that's a formula you want to have, S equals R theta. So they're asking me for, and that's for arc length. Whenever you see arc, length of arc, use that formula. That's the arc length. So what we're saying is, hey, if you've got an amount of opening, an angle theta, and you're at a radius r, and you want to know how long the arc is, we call that S. I don't know why we call it S, but the length of that arc, S, it's r times theta. Mr. Avery, down the hall. All right, S equals R theta. We good? We good to there? Okay, S equals R theta. So let's just solve it. You ready? S equals R, 18, times theta. What's theta?
230.
Yeah, I don't know if you can see it, small print there. R is 18. Theta is 230 degrees. 18 times 230. Is that good? Somebody got that? What's 18 times 230?
4,140.
4140? There's not degrees anymore. It's arc length. 4140. We good there?
So where does the degrees go?
It's not degrees anymore. It becomes arc length.
But if you're multiplying 18 times 230 degrees, where does that?
Yeah, so it's just like, so your question is a physics question. So this is wrong. The reason this is wrong is when you use, so I want to make a big deal out of this so you remember, when you use S equals R theta, theta must be in radians. It can't be degrees. You cannot, the formula simply does not work. It's not true in degrees. That formula is only true if theta is in radians. So let's go back and let's change theta to radians. What's theta? Theta is 230 degrees. How do we change that 230 to radians? Is there a pi already there? There's not, so we got to bring in our own pi, huh? And so now, which way does it go? Remember, because pi and 180, that's the bridge between the two worlds, radians and degrees, right? So which way do we go? This 230 is over 1. So where am I going to put the 180 degrees?
On the bottom.
On the bottom, so that degrees
That's
will
where
go
the
away,
degrees goes away.
and the pi will be on the top. Yeah, in this case, it does. So does that make sense? Everybody see what happened? I'm converting. Can you see that? It's just not very nice writing. Let me try again. So that theta. In fact, let me just put it over here. We got a little room. So theta's 230 degrees. So I'm going to take theta 230 degrees, and I'll change this to radians, times pi radians over, not 230, what do I do? 180. 180 degrees. Everybody see that? This is over 1, so degrees cancel. So theta is 23 pi. Can I just cancel those zeros? I just cancel them. Is that okay? I skip that step. 23 pi over 18. Just cancel the divided by 10 top and bottom. 230 and 180. 23 over 18. 23 pi over 18. Now it'll work. Now your R is 18. Now put in your theta 23 pi over 18.
Which is 23 pi.
Yeah, do you see that
The 18s cancel out.
we're going, I don't want to race too fast ahead of you. You with me? See what I've done? I took that theta on the side, took the 230 degrees, I converted to radians with the bridge, pi 180 bridge. Cancel, got the radians. This formula only works in radians. Pop it in there. This is 8, whole numbers are always over 1. 18s cross cancel, 23 pi. That's the arc length. Yeah?
You can't just change the answer to radians?
No. Well, I mean, it would work in this case, but is that true?
I think she's asking if we took.
Yeah, you could change it at the end
if we
instead of in the beginning. Yeah, that would actually work. Yeah.
So if we
Good
took-
on this?
If we took the answer 4140, and is that
Mm-hmm.
what she's asking?
Mm-hmm. Right. Took the answer 4140 and converted that.
Put it back, and that
Right.
would work?
It's a little sketchy. I mean, what I mean is that answer, that final answer, 4140, is not really degrees. That's why I say it's, if you did that in calculus, your teacher would kind of give you one of them looks like, yeah, you made that work in the end, but that's ugly. Because, why? Why am I saying it's ugly? Well, 4140 is not really
That's
degrees.
a lot of work, though.
4140 is not really degrees. That 4140 is no longer degrees. We got it from 18 times degrees, but it's not degrees anymore because it's r theta. What is it? It's something kind of weird. And then you do the converting like it was degrees to radians, but it really wasn't degrees. That's why people would kind of frown at that, even though you can make that work. This is a true conversion from degrees to radians, and then this is the true answer.
I have a question too. Just because I kind of forgot this, but let's say the 18 to the left is like 13. How would you multiply that with the pi involved?
Yeah, if that was like a 13 that didn't cross cancel, you would just go top times top. Good question. Probably a lot of people are there. Yeah, if it doesn't cross cancel, then you just multiply top with top and bottom with bottom and just leave it.
Oh,
Yeah.
Do you simplify it?
If you can. You always simplify if you can. But yeah, if nothing simplifies, just go top, top, bottom, bottom. And leave it. Yeah. Yeah, you know what? Cross cancel. Yeah, let me say one more word because I want to take the mystery off of that. You know what cross canceling is? It's just early simplification. That's all that is. You know, think about it. Let me give you a simple example. What if you had 2 times, I don't know, 7/8? No, let's go 3/8. Yeah, that's a perfect example. So what if I had 2 times 3/8? Okay, I could go 2 over 1, whole numbers over 1. And you could just, if you wanted to, now those cross cancel, right? 2 does go into 8. But what if you wanted to skip? Well, I'm just not in a cross canceling mood. That's okay. You can go top times top, 2 times 3, 6, 1 times 8. You can always go top, top, bottom, bottom. But then what would you have to do with 6/8?
Divided by 2.
Because you didn't do it early.
Right.
See, cross canceling is just early simplification. Back when the numbers are small, before they get bigger. It's just an easy way, right? Because then you'd have to go divide by 2, it'd become 3, 4, 6. Which would have happened if you just would have went like that right in the beginning. So let me just take the veneer off of cross canceling. It's just early simplification. That's all it is. That's all cross canceling is you're just dividing the same number out at the top and the bottom.
So the numbers don't have to be the same to cross cancel, they just have to be divisible by the.
By the same thing. There just has to be something that goes into both of them. Yep. That's all it
Preferably
is.
something that makes that one a 1.
That'd be
Oh, it
nice,
doesn't-
but it doesn't have to
doesn't
be.
all-
No, it doesn't have to be. It's just simplifying. That's all it is. It's just dividing the same number out. Okay, so how do I know I want to use that? Well, it says find the area of a sector of a circle. So area is a half r squared theta, but again, theta must be in radians. So let's do it. So area is a half r. What's r in this problem?
8 inches.
Oh yeah, radius right there, 8 inches. R squared, 8 squared. Right, so there's the r. Theta. And what's theta? 120. Yeah, but I can't do 120. Back up on that. No. That's degrees. Theta must be in radians, huh? So before I can finish this up, 1/2 r squared, r is 8, r squared, theta. Before I put in that theta, I've got to figure out, I've got to change theta to be in radians. So we better do that. So bring that over. Bring it over here. Theta, which is 120 degrees. How do you convert from degrees to radians? What's the bridge between the worlds?
180.
Yeah, multiply. Where's the 180 going to go?
On the bottom.
Bottom, because you want degrees to go bye-bye. So pi on the top, that's 12 pi over 18. It's divided top and bottom by 10. Is that okay?
Yep.
And I can reduce that again, actually, huh?
Right.
What goes into 12 and 18?
6.
6 does. So I can divide. You could do 2 or 3, but 6 is even quicker. Divide by 6, you get 2/3 pi. That's the same, by the way, as 2 pi over 3. Do you know I can put the pi in the front or the top? To be in the front is the same as to be in the top. Why?
Right.
In the front, you're over 1.
Right.
You're in the top. It's all the same thing. Did you track with that? If I write 2 pi over 3, that's the same as 2/3 pi. Both those are the same. Either way you want, it's good either way. You aware of that kind of thing? To be alone is to be over 1, is to be in the top. It's all the same thing. To be alone is to be in the top. It's the same thing because you're over 1, right? So either way, doesn't matter. So 2/3 pi. So what does this come out to be? A half times 64 times 2/3 pi. So how do you simplify that? Well, 64 is over 1. Cross cancel. 2 goes into 64. 32 times. So then multiply top times top. 32 times 2. 64 over the bottom. 3 pi. 64/3 pi. Or you can put the pi on the top. Same thing, whatever. Is that too quick at the end there?
No.
See what happened? The 2 was underneath, cross-canceled the 64, right? Bottom to top?
Could we have
Diagonal?
cross-canceled the 2 2s?
You could have. Yeah, that would have been even slicker, huh? I should have just done that. That would have saved time. Let me redo it. I like that. So, yeah, even
I
better.
don't know if that would have worked for every problem.
Yeah, you can cross-cancel by the thing right next to you or way on down the line. As long as they're all just multiplied, it's all fine. That's right. See all the rules of algebra we're learning? Yeah, you could just cancel these guys instead.
That's why I like
And that 64 goes to the top because he's over 1. Same answer. Either way.
Then you don't have to worry about what.
Yeah, 32 and remultiply and all that. Good. Ooh, I'm looking at 10 minutes. I want to get a couple more of these done for you. All right. 5 minutes, 50 seconds. Find the positive radian measure of the angle that the second hand of a clock moves through in the given time. The second hand of a clock moves through in the given time. The second hand of a clock. Okay, so how much angle? So what we're talking about is a clock, like that clock up there on the wall. Look at that little red hand. That second hand is, that's what I'm talking about, the second hand. See them say that? The second hand, the one that marks off the seconds. So that's like that little red one. It's ticking away the seconds. So in 5 minutes, let's just do the 5 minutes first. We'll get to the 50 seconds in a minute. The pun, sorry. All right, so let's do the 5 minutes first off. What does that little red hand do in 5 minutes?
Goes around 5 times.
Goes completely around 5 times, doesn't it? So first off, it's 5 times 2 pi. They want radians, don't they? Yeah, radians, yeah. So 5 times 2 pi, 5 full times around in 5 minutes. Now what about the 50 seconds? It doesn't quite make it all the way around again. In 50 seconds, what portion of the circle does it complete?
Almost all of it.
goes to the select, well, on the clock, it would be the first.
50
or it would be the
60ths
second.
of all the way around. Right? Doesn't it do 50 60ths? Because 60 seconds is all the way around. If I said, hey, I had 60 jobs to do and I did 50 of them, well, then I did 50 60ths of the whole job.
Yeah.
Right?
So 5, 6.
If that hand has 60 seconds to make it through to make a full circle, and it does 50, doesn't it do 50 60ths of a whole circle?
Yeah.
So it does 50 60ths, that's the portion of in math is always times, of a whole circle.
And I have a question for you. Since we're talking about a clock, and the clock goes the negative way, would those be negative or no?
A good question. They don't. Yeah, they're not specifying positive or negative here. So yeah, they'll let us skip that. But you're right. Good point. Normally it'd be negative. Well, maybe they would make. Oh, find the positive radian measure of the angle that a second hand. Yeah, they're just saying they want it positive. I don't know why. Yeah, good. I'm sorry, I didn't think about that. So we good so far? So 5 full 2 pi's plus, in addition, 50 60ths of another 2 pi.
Okay.
That's the total rate, even though it's technically a negative angle, you're right. That's the amount it moves through. So how do we do that? 5 times 2 pi?
10 pi.
That'd be 10 pi. 10 pi plus, now what do you do here? Cancel these. It's 5/6 of 2 pi. You tracking with me? 5/6 of 2 pi.
Right,
And what do you do with that 2 pi? Put it over 1?
right. So 10, 6. Or you cross cancel the 2 and the 6.
Yeah, well, yeah, either way. Let's just go straight. Okay, so 10 pi over 6. Or you could have made it 5 pi over 3. Either way. We good to there so far? 10 pi, 5 2 pi's, and 5 times 2. You could correct. That bug you? I did. Yeah, I'll do that. All right, that bugs you. I'll make that 5 3. It's either way. Either way is totally good. 5 pi over 3. That'd be a little simpler. So we have 10 pi plus 5 pi over 3. We good so far? Am I losing you? I feel like I'm losing you a little bit more now on this one. Is this making sense? 5 full circles. Second day goes around 5 full minutes, and 50 60ths of another full circle. Reduce that, 5/6, 2 pi, put it over 1, cross cancel, 5/3. How do you add 2 things?
Make a comment on it.
Put over 1, top and bottom by 3, 30 pi over 3, plus 5 pi over 3, 35 pi over 3. There it is. 35 pi over 3. That's the angle it goes to. Let's make sure it takes that angle. Take a look for a second. Okay, so they have this road sign. They want me to find out how, they're each going to be the same. How big is that arc? That's basically what it's saying. Find the length of each of the arcs. So how big is that arc? What's our arc length formula? R theta, but theta in radians, huh? So what's the radius? They tell me right here, 22 inches. Radius 22. What's the theta? What's the angle? Well, that's a right angle.
Right.
Theta is 90 degrees, but that's degrees. What is that in radians? Times pi over 180. Cancels 90 pi over 180. Pi over 2. Pi over 2. As you put this over 1, cancel 11 pi. Not too fast? I know I'm kind of whipping at this point, huh?
You're good.
11 pi over 2. Did you see that? So it was r theta. The r was 22. The theta, that was pi over 2. 90 degrees is pi over 2, huh? So pi over 2. Cancel 11 pi. Let's see. Okay. 2 cities, A and B, 8,000 miles apart, radius of the Earth, 4,000 miles. Press the angle. Yeah, you can actually do this to find angles between 2 locations on the planet. This is all the kind of stuff that goes into global positioning and all that. GPS software and all that kind of stuff that programmers do. So this is the math behind all that. So if you go there, there's the center of the Earth, and you see in that picture. I'm about to fall over. I guess I'm getting tired. There's the center of the Earth there, and the radius of the Earth is 4,000 miles. Did you know that number? I didn't know that number. So so the radius of the Earth, 4,000 miles to the center. how far apart are A and B on the Earth? Notice, distance on the Earth is not actually a straight line. It's an arc curve, isn't it?
Yeah.
Normally we're so close. If you're close, it's almost the same thing. But if you're further away, I have some friends that just flew over the North Pole 2 weeks ago to land halfway around the world in Abu Dhabi, the United Arab Emirates, becoming missionaries far over there. Anyway, so that distance is an arc, isn't it? It's actually, you'd have to use the arc formula. S equals r theta. It's arc length. Interesting little arc formula. So we just use S equals r theta. So here we go. They're saying the arc, the S, is the distance the two cities are apart. That's the 8,000. The distance two cities are apart on the Earth is actually an arc, isn't it? It's actually an arc. We think of it as a straight line, but it's actually an arc length. So they're saying cities A and B, yeah, because we know the Earth is not flat. Right? It's right. So therefore, it's technically an arc. So when cities A and B are 8,000 miles apart, that means that arc is 8,000 miles, huh? So that's actually the S. That goes here. That's the arc length. The radius, that's the 4,000. So what they're asking is, what's the theta? What's the angle between the two cities? If you're at the center of the Earth, measuring the angle between cities A and B, what would that angle theta be?
2,000.
Yeah, divide by 4,000 on both sides. Theta's 2. To what? To radians. Remember, you're automatically in radians when you use that formula. By default, you're in radians when you use the S equals R theta formula. So it's 2 radians, and then they have you change that to degrees. How do we change 2 radians to degrees? What's going to go on the bottom? This is over 1. What do I need to cancel? This one's going the other way.
So the 180 goes on top.
Yeah, the radians, pi radians needs to go on the bottom that time because you want to go out of radians, don't you? Did everybody see that stuff? Remember, that's what I learned in chemistry. Actually, I didn't get it on the first exam, and I did them all the hard way. Then right after the Chem 3A exam was over, I remember going, oh, you just put on the bottom what you want to cancel. Then it seems so easy after that. So do you get the idea? You always put on the bottom what you want to cancel. I want radians to go away. So pi radians, I want to go into degrees. So then that's going to be what? 2 times 180, 360 over pi. If you divide that in your calculator, I guess you get 115 rounded to the nearest whole number. Just take 360 divided by the pi button. It comes out 115 degrees about. Well, we're out of time. We're over time. This is what I always do. I always go over time. No extra charge for the extra time. Sorry, I just always want to finish. You're probably